Hey, welcome back. I hope everybody's doing okay. Let's continue on with Unit 6. We are going to move into Lesson 10. Still working with square roots, but this time we're going to be working with square roots of monomials. So that just means we're going to start bringing in terms that have variables as part of the term. So let's get right to it here. Monomial square roots. This is what we're talking about. And since I know this is really small, I think what I'm going to do is write the notes here on just regular line paper. And this might be easier for you guys to see. When we talk about square rooting monomial terms, we're talking about things like this. For example, the square root of x to the second power. Now, as with most things in math class, there are multiple ways that you can do this. I'm going to show you my favorite way. Obviously, you probably know what the square root of x squared is, but let me show you how you could break that down into x times x, right? And remember in the previous video when we were talking about square roots, I was telling you that when you broke your term down into like its prime factors or into its factors or pieces, if you were square rooting and you saw two of the same term, like a pair or a couple, you could circle them and know that the square root of those is just one of those. And I would say things like you factor it out. So the answer here would just be x. The square root of x squared is just 1x. So let's do another one. What would be the square root of m to the 6th power? Okay, well, really, look, here's what it means. Six m's, right? Check it out. There's a pair, there's a pair, there's a pair. So an m comes out, an m comes out, and an m comes out with nothing left behind. That would mean the square root of m to the 6th is m to the 3rd. Okay? Because it's m times m times m, so m to the 3rd. What about a different way to think of this? If you're catching on to the fact that we can pair up our terms in groups of 2, another way to think of this is you could take m to the 6th and break it down into m2, m2, and m2, right? And that's still 6 of them, right? It's 2 here, and that would make 4, and that would make 6. But if you know you need them in groups of 2, you could simply break them into groups of 2. Then the square root of m2 is m, square root of m squared is m, square root of m squared is m. So you're taking m, and m out. So that's, again, m to the 3rd. It's just all another way of breaking down these variable terms. You can break them down into their individual pieces and look for pairs. Or if you want to think about a pair as m squared, you could do it that way as well. There are lots of different ways to think about these types of problems. Let's do one now where the monomial includes a number. The square root of 9k squared. So here's what I would do. 9 is 3 times 3. K squared is k and k. There's a pair. So that means you bring one out. That comes outside. There's a pair. So you bring one out. That comes on the outside. There's nothing left underneath the radical. So your answer is 3k. Maybe this was one where you could look at and say, Ms. Glessner, I know that the square root of 9 is 3, and I know that the square root of k squared is k. Yeah, either way, I don't care. I'm not saying there's only one way to think of these problems. And obviously right now we're doing some pretty simple problems. They're certainly going to get more difficult. Let's do some more. How about the square root of 64p to the 4th? I bet you know that the square root of 64 is 8. And P4 is really P2, P2, right? And the square root of P squared is P, and the square root of this P squared is P. So you take out a P and another P, you took out two of them, so it's 8P squared. All right, how about this one? Square root of 100 x2 y2. Can you tell me square root of 100? Sure, it's 10. Square root of x squared, which is really x times x, is x. Square root of y squared is y. So the answer is 10xy. Not too bad, right? Let's do another one before we move on. Square root of 49, a2, b6, c4. Square root of 49, 7. Square root of a squared is just 1a. Now b6, that's b2, 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 right? So the square root of b squared is b, and another b squared is b, and another b squared is b. So that's really b3. And c4, well, that's c2 and c2. So you would take out a c and another c, c squared. So again, if you want me to show you what this looks like for just the variables, it was 2 a's, 6 b's, and 4 c's, right? So I stretched it all out. Look, there's a pair. That's where this a comes from. 1 pair of b's, 2 pair of b's, 3 pair of b's, b3, 1 pair of c's, and another pair of c's, 2 pair of c's. So there's an a b, a b, a b, a c, a c. Does that make sense? I hope so. So then that leads us to the next part of the notes, where it says right here, it is only possible to take the square root of variables with blank exponents. And the word that's missing here is even. We need even exponents on our variables in order to take the square root. So if we have a variable that has an odd exponent, I'm going to show you how to handle that, how you break it apart, and then something's going to get left underneath the radical, and some things are going to get pulled out. For example, the first one we're going to do, maybe we have room on here. This says the square root of y to the 5th. Well, that is an odd exponent, but let's break it down. Five y's, right? Look at a pair and a pair. So one y comes out, another y comes out, leaving behind one y under the radical. So you took out a y and you took out another y. So that means you got y squared sitting on the outside of the radical. And what do we have left inside? One lonely y, square root of y. And that's the answer, y squared, square root of y. Isn't that weird? Let's do this one. This one says the square root of a squared b3. So break this b3 down into a b2 and a b, which is a b1, right? So we took that b3 and broke it apart into the evens, and then there's that little oddball out there by himself. So the square root of a squared is a. The square root of b squared is b, leaving behind that little lonely b to the 1st power. That's the answer. Let's keep going. This one, square root of x squared y3 z4. Odd exponent, it's going to be x squared y, z2, z2, right? Does that help if we break them apart? Square root of x squared is x. There's an x that comes out. Square root of y squared is y. There's a y that comes out. Z squared is z, and another z squared means two of those, leaving behind just one lonely y under the radical like that. So it's x, y, z squared, square root of y. It's like I'm speaking a different language. All right, let's keep going. Now, the monomials are, again, have coefficients, right? They have numbers as part of them. So 45 n to the fourth. All right, so we have to find the square root of 45. Ooh, that's not a perfect square number, is it? Nope. So here we go again. I'm going to recommend that you prime factor that 45. Honest to God, I think at this point, and the fact that we're not in class together and so on and so forth, this is probably the most reliable way to do it. I'm going to prime factor 45. So now I'm going to break that 45 down into a 335. Now, N4, I'm going to put it into N2 and N2. Now, square rooting, we look for partners. We look for couples. That can get factored out. That's going to get a factor out, and so is that. What comes out of here? A 3. What comes out of here? An N. What comes out of here? Another N. So another N really makes 3n squared, right? What's left behind? A square root of 5. So that's your answer. 3n squared, square root of 5. Cool, huh? Not too bad. Let's do, I don't want to do all of these because it just takes so much time. Oh, these are all perfect squares. Okay, well, we can do 11. We can do, well, no, let's jump down and do 13. Let's do this one. Here's what it says. 100, x5, y2. I bet you know the square root of 100, right? Is 10. That takes care of that. x5, that's x2, x2, x. So instead of x5, x2, x2, and x. That makes x5. Square root of x squared is x. Square root of x squared is another x. That takes care of those. This guy gets left behind. And then don't forget, square root of y squared is y. So we can condense that to say 10 x squared y square root of x. Right? Awesome. Good job. And I think we'll stop. Should we do 50? 50 is when we're going to have to prime factor. Let's do that one. Let's do number 16. It says the square root of 50 x squared. Let's break apart 50. I would say 5 and 10, and 5 and 2, 2, 5, 5, x squared. There's a couple. Take that 5 out. There's a couple. Take the x out. Leaves behind a square root of 2. 5x square root of 2. Not too bad. In fact, honestly, I mean, the math nerd in me thinks this is kind of fun. It's almost like a, once you get good at it, it's almost like a puzzle. I don't know. We have a few more to do. They obviously get a little bit more difficult. No worries. We got this. Here we go. It says the square root of 63 x squared y5 z2. 63 is not a perfect square. Let's prime factor 63. What times what is 63? Well, you could do 3 and 21. and 3 and 7. That works. So it's 3, 3, 7. X2. Y5, I'm going to break apart. Y2, Y2, and Y, and Z2. Now, oops, I'm so sorry. So there's my 3, 3, 7, my X2. This becomes my Y5, Y2, Y2, when Y, and then a Z2. So I just broke it all apart into pieces that are going to be easy to take the square root of. I see a pair. That means a 3 comes out. Nope, nothing to do there. An X comes out. A Y comes out. Another Y comes out. That stays in. And a Z comes out. So that means I have 3x y squared z square roots of, I should put 7y, right? Those guys got left behind. The 7 and the y get left behind. Da, 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 da. Well, you want to do this one? Sure. It says the square root of 108 r squared s to the third t to the sixth. I would encourage you to prime factor that 108. It can become a 2 and a 54. And this can become anything you want it to be. How about 2 and 27? And a 3 with a 9. And a 3 with a 3. Wow. Okay. So it's a 2, 2, 3, 3, 3. Now, R2 can stay. S2 and S1, that makes S3. T2, T2, T2. Right? So that makes T6. A pair, that's a pair, that's a pair, and then pair, pair, pair. Got a lot of stuff to take out. Take out a 2 and a 3. So if you take a 2 and a 3 out, really that's going to become a 6. 2 came out, 3 came out. An R comes out, an S comes out, and a T, and a T. That's those guys. Leaving behind that 3 and that S. So again, you got to look back at what you took out. The 2 and the 3 you took out get multiplied to become a 6. I have an R, I have an S, and a T to the third power with 3S still inside. That's your final answer there. Holy cow. Let me see. That would be another good one. I don't want to do all of these. It's too much. Let's do this one. Last one. Square root of 252 x y2 z3. Remember that x is really an x1. Let's prime factor 252. It's going to take me a minute. We could do a 2 with a 126. I believe that works, right? Yeah, that's right. And then a 2 with a 63. Yeah. And a 3 with a 21. And a 3 with a 7. Holy cow. 2, 2, 3, 3, 7. I'm going to break apart that Z3 into a Z2 and a Z1. Look for my partners or my couples. A 2 comes out, a 3 comes out. A Y comes out, a Z comes out, leaving behind a 7, an X, and a Z. 2 times 3 makes 6, Y, Z, square root of 7, X, Z. What do you think about all that? Finding the square root of monomials. Are there other ways to do this? Yes. Are they any less confusing? No, I don't think so. I think this is, for now, the best way to teach you how to do this. Okay? So, thanks for watching. You can always contact me via email if you have questions. If you want to set up a Google Meet time with me separate from what I have set up for the entire class, of course I can accommodate you in that way. I'm currently recording this video, by the way, at 5:30 at night. I've been sitting here in my kitchen at my desk since 7:20 this morning. So to say that I'm available is an understatement, okay? I am here. Even though you can't see me, I'm super easy to reach. Do not hesitate to reach out to me if you have any questions or confusion or comments or concerns. I can't make it any better. All we can do is try, right? And that's all I'm asking you to do as well. I'm just asking you to try, okay? So I hope all is well with you and your family, and I will be in touch with you again real soon. Bye-bye. Take care.